There's something really special about the Android community. As we travel around the world and meet developers, we're really struck by the spirit of innovation and helpfulness, and really how everyone is working together to build a better Android.
I'm so excited to go to Android Dev Summit and meet the developers I've been following online since I started learning Android.
The Android Developer Summit for me will be my first. I'd like to hear about all the awesome new libraries and things that Google has planned for us as Android developers.
As a platform, we build the foundations, the building blocks, the tools, but really the way that developers take those technologies and create new businesses, new apps, new games on top of it in ways that we could have never imagined is just so special to see.
I didn't have a degree to back me up, but I started participating in Android meetups. With this little community of people online, I felt more and more confident on my skills. I wouldn't have thought that in 7 years you would be running your own Android meetup. I would have said, you're crazy.
The Android community has been hugely influential to where I am today. You've got a massive community of people to reach out to, something that you actually depend on for your career. It's not all about tech, it's also about giving back.
It's so inspiring to hear stories about developers like Zara and Nick who have had a chance to join the community, grow through it, and are now giving back and helping others grow.
Giving back to the community and being involved in it as you can is vitally important to this whole ecosystem of Android.
This is a really good feeling to be with people who speak the same language as you, even though we're all from different countries, but we all speak Android.
Welcome to the stage, Dave Burke.
All right, hello everyone, and welcome to the 2019 Android Developer Summit. It is awesome to have so many developers here to talk about the hottest topics in Android development. So in addition to the many Google engineers we have today, we have over 700 developers in person from 65 countries, as well as thousands of you joining on the live stream. So welcome, everybody. Now, computing has gone through a pretty amazing evolution in my lifetime. I can clearly remember my first computer. I was 8. It was a BBC Micro from a company in the UK called Acorn. And I can still recall that feeling of wonder, of possibility, where I could dream up ideas and bring them to life. I remember my primary objective being 8 was to build a defense system to protect my bedroom from my older sister snooping. And so I rigged a photoresistor to the analog joystick port, and then it could detect an intruder breaking a beam. And then I used, I think it was a cassette motor relay to fire a peg gun and then shoot intruders. I get on a lot better with my sister nowadays, so that's good. The company that built the BBC Micro, Acorn, it went on to design one of the first commercial RISC PCs. It was called the Archimedes. And then in the early 1990s, they set out and created a startup, little known at the time, called ARM. And of course, today, billions of phones around the world are powered by ARM's RISC processors. And the other ingredient you'll find in these phones, of course, is Android. And this is the part of the keynote where I usually mention the 2.5 billion devices. But when the Android team began, the team didn't know for the first couple of years if there would even be one user, let alone if the project would continue. And there were many companies thinking about and working in this space at the time, and it wasn't clear that Android was the one that was going to shine through. But 14 years later, here we are, and Android's powering not just phones and tablets, but auto and wearables and TV and so on. And part of why this happened was, one was a team that worked, really, really hard on this platform. But a lot of it was also timing, right? It was a convergence of hardware capability and an industry that needed this kind of platform. But a huge part of it was the ecosystem that built up around Android, from the device makers to you, the app developers. And building an ecosystem is just a really hard thing to do. It's something we strive hard to do well. And it's why we get excited by events like today, where we get to spend time together and to envision a future together. Because for many reasons, you are all a reason for why Android has 2.5 billion devices. Now, usually when I talk about Android, it's typically an I/O setting, and I'm talking about the next release. What I wanted to do today was just talk about 5 distinct work streams that I think are important for Android for the next 10 years. So first up is something we call helpful innovation. So when we design features, when we're thinking up ideas for Android, we want to build features that help users feel empowered and productive, and that simplify things in ways that are easily understood. And so one recent example of helpful innovation is Android's emergency location service. And today, 80% of emergency calls, unsurprisingly, originate from mobile phones. And historically, the challenge has been that the location that the emergency responders get from such a call is limited to cell ID, which has a radius of several miles. And the FCC in the US estimates that if you reduce the response time of an E911 call by just 1 minute, you can save 10,000 lives a year. So we set about building this emergency location service into Android, and it's available now on 99% of Android handsets. And what we do is we combine all of the location technologies in the phone, so cell ID, Wi-Fi, GPS, et cetera, to dramatically improve the location accuracy. And now British Telecom estimates that for their emergency calls on their network, they're now seeing radiuses of about 50 meters for their emergency calls, which directly translates into saving lives. Speaking of safety, just last week we launched a new feature initially on Pixel 4 that detects if you're in a severe car crash and helps you call for help. And this feature uses high G accelerometers and audio machine learning. And we were motivated by the fact that car crashes are one of the top 10 causes of death, certainly in the US, for most age groups. By the way, if you were wondering how we tested for true positives for this feature, here's a quick video. So this car is armed with 20 Pixel phones. And before you think we're being wasteful, I just want to point out that we reused the same car for multiple crashes, so it gives a whole new meaning to my phone keeps crashing. I'll be here all week. Anyway, so we're exploring ways to bring this to the ecosystem more broadly. So another example of helpful innovation is around the hardware itself. And today there's an overarching trend in the industry around maximizing the screen area. And broadly, there's two paths being taken. So on the one hand, device makers are sort of striving for this holy grail of edge-to-edge glass. And it's a really hard problem because you've got to find a place for the front-facing cameras, the earpiece, the proximity sensors, antennas, so on and so forth. But year on year, it's getting there. The other path takes a step back and uses novel technologies such as 360-degree hinges and foldable glass. And recent examples of this are the Samsung Galaxy Fold and the Microsoft Surface Duo. And we're working closely with the teams at Microsoft and Samsung to optimize Android for these form factors. Already, Android 10 takes advantage of dynamic displays by adding the ability for apps to indicate if they support resizable activities, and as well as enabling multiple simultaneous resumed activities. And these features enable a key experience that we call app continuity. So the idea is you're using the app, and then you can unfold or open the device, and then the app stretches to fit the larger display. And of course, all these features help your apps perform better on larger screen devices, like the 175 million Android tablets, as well as Chromebooks. So the second work stream is something we call updatability. So Android's a unique project. It's not a single product, as you know, but it's an open source platform that runs on devices of all shapes and sizes from different manufacturers at wildly different price points. And Android doesn't have a challenge of running, initial versions of hardware typically run on the latest version of Android. But the real challenge for us is ensuring that devices already in the hands of customers continue to get timely updates. And it really boils down to economics. So thanks to efforts like Project Treble, which separates the hardware-specific code from the operating system, we've reduced the cost of updates. And we're starting to see progress here. So for example, Android Pie grew at 2.5 times the rate of Oreo, and Android 10 is projected to grow at 5 to 6 times the rate of Oreo. And you can also see the effect of Project Treble in our beta program. So this year, we had 21 devices from 13 OEMs participate. Security updates have also improved. These are the smaller patch updates. And today, almost 90% of devices that have launched since the beginning of 2018 receive quarterly security updates, and we're working on improving that further. In Android 10, a Project Mainline, now called Google Play System Updates, standardizes modules across different manufacturers, as well as provides a channel for that code to be updated through Play Store. And Android 10 has several updatable modules, everything from cryptography to aspects of the media framework. And this was a really huge foundational undertaking for us. First, we had to create a new packaging format called Apex. If you're wondering, that stands for Android Pony Express. It's the best thing we could come up with. It's like an APK, but it runs at boot. That's the main difference. Then we created file system snapshotting. So the idea here is if we inadvertently pushed a module that caused a battery regression, we can roll the module back, but then also revert the file system back to its original state. And then third, we had to create new release machinery so that we could do stage rollouts, A/B updates, long and short window telemetry, and so on. And so we think this progressive software deployment approach is going to be a huge benefit for Android over the years. And as the number of updatable modules increases, developer fragmentation reduces as the devices get more consistent. The third multi-year effort for us is around security. Now, Android uses layered defenses to keep users safe. For example, Android 1.0 launched with kernel-level app sandbox protections. And then we later added SE Linux on top to provide access control to separate apps from the system and apps from each other. And then ASLR adds address randomization on top of that. Then we introduced hardware-enforced verified boot to prevent devices from being tampered with. And then Google Play Protect adds an anti-malware layer of protection on top, scanning billions of apps every day. But probably one of the strongest aspects of Android's security story is that it's open source and cross-platform. And that means it's open for scrutiny by people and organizations, and as a result, gets a lot more people looking at it than a proprietary OS. And code that runs on heterogeneous hardware is, by definition, more robust. So then it comes as no surprise, certainly to us, that the bug bounties for full-chain exploits on Android from companies like Zerodium now exceed that of iOS. And by the way, if you can find such an exploit in Android, it's worth $2.5 million to you today. And it's also no surprise that in Gartner's 2019 security report, Android Pie scored the highest possible rating in 26 out of 30 categories. So security is all about protecting your data. The other side of the coin is privacy, so giving users control of their data. And when Android first launched in 2008, we deliberately designed the platform to be very open and customizable. And this led to a ton of innovation, which has been fantastic. But along the way, we also learned of some unintended consequences of some of the APIs. And as users, as we become more dependent on our phones for our digital lives, and as the apps themselves get more sophisticated, our expectations of privacy are shifting. And for that reason, in Android 10, we added over 50 features and changes related to privacy. And I wanted to call out one in particular, background activity starts. So there are, of course, lots of legit reasons that you would have background activity starts. For example, the dialer when an incoming phone call is received. But we also found that this capability was open for abuse. And it's really bad when it happens. So here's an example of the problem. You're navigating in your car, and all of a sudden a pop-up ad appears and forces the navigation system to go into a picture-in-picture. And if you think this is a theoretical scenario, here's some real-world feedback that we received from somebody who actually saw this happening on their driver's phone, rather. And so it's pretty scary. And this is an incredible stat, but we estimate that phones running Android 10 blocked over 17.8 million advertising pop-ups in the last week alone. So tackling privacy is super important, but it's also really hard, right? And so we want to make sure that we do changes in a thoughtful way without breaking the app ecosystem. And we've heard from many of you that these changes can be painful, like scope storage. And we took your feedback there and made some changes. And we're also planning on soliciting your feedback earlier in the release for the next coming year. The fifth work stream is really the theme of this whole summit, great developer experiences. And perhaps, as a consequence of Android's flexibility, we often get asked, what does the Android team recommend when building apps? And we call our recommendation modern Android development. And modern Android is opinionated and powerful with a more complete platform. And it's all about helping you focus on what you do best, which is building amazing experiences. And you can see it in investments that we're making in Android Studio, in Jetpack. And Kotlin and Compose are two especially great examples. So Kotlin is a modern, concise language, and it's something that you asked for and is now the recommended language of Android. And Compose is a modern declarative UI toolkit designed for the next 10 years. This might sound a little strange, but we chose and designed these tools to also be enjoyable to use. We think that's important too. Both Kotlin and Compose also have this really critical property. They're designed to be compatible with your existing apps. And this means that you can phase them in on your timeline. So you can bring in Kotlin code and Compose views when you're ready. In fact, we just reached a milestone where almost 60% of the top 1,000 apps now are using Kotlin. OK, so that's a quick insider peek into how I'm thinking about Android. It's time to get this thing started and dig in a bit deeper. And so I'm excited to invite Steph up to the stage to take it from here. Thank you.
Hi, everyone. So Dave started us off with a window into some of his long-term thinking and how it's shaping Android. Today, I want to shift gears now, and let's focus on developers and what's coming for you today. So today, Android's momentum is amazing, with over 2.5 billion users, as Dave talked about. But today also marks another new milestone. There are over 116 billion installs on Play in the last year. It's a platform that's making so many developers successful. Now, at Google, we see our role as shepherds of the platform. In the beginning, this was all about protecting Android's openness with a powerful, flexible operating system. But more recently, that's changed. Developers have started to ask us, what does the Android team recommend when it comes to building apps? Now, you've told us, keep the openness. But you also want us to become opinionated about the right way to do things, and to make the right way the fastest way. So the fastest and the easiest way. And so we are. The team calls this modern Android development. Modern Android is all about helping you focus on what you do best, opinionated and powerful for fast, easy development. Taking away everything that slows you down so you can focus on building incredible experiences. It also means being open to new ideas that can make Android better for you. Each one we want to consider carefully before we bring it to the community, because we have to make it work at scale for millions of developers who have billions of lines of code. You can see modern Android at work in Jetpack, in Kotlin, and in Compose. Kotlin is a great example of something that you asked for, we adopted, and this year we're moving to a Kotlin-first design in our APIs. Compose is a modern UI toolkit that really leans into the idioms of Kotlin, giving you a great UI development experience, together with direct platform access, backwards compatibility, and the performance that you need. Now, all these ideas originated in discussions with our community. And you told me it's obvious how much Android is listening to you. I am glad, because we are. Modern Android is really about working together, from ideas like this to working in the open completely, like Compose, to the more than 50,000 bugs that have been filed this year by you across every area of Android. In fact, we flew one of our top bug reporters here from Europe today. Marius, can you please stand? To give him a round of applause. In today's keynote, you'll see how modern Android and this thinking is shaping all three platform pillars. We'll talk about development tools, distribution, and the OS itself. First, modern Android tools and APIs. I want you to hear from Ramon and Karen about what's new in the IDE, in Kotlin, and Jetpack, as well as Compose, the new modern Android UI toolkit. Next, for modern distribution, I want you to hear from the Vice President of Play and his hard work to help apps and games succeed and grow even faster, as well as do it safely. And finally, I will be back to talk about the future of the Android operating system. So with that, can you please welcome Karen to tell you more about our developer experience? Thank you.
Thanks, Steph. Hi, my name is Karen, and I run the product team for Kotlin, Jetpack, and Android Studio. Modern development starts with a language, and we added Kotlin officially because you wanted it, and it was the right choice. We're seeing incredible adoption across the world. Almost 60% of the top 1,000 apps on Play are already using Kotlin in production. 53% of pro Android developers use Kotlin. And since May, we've seen 20,000 developers attending Kotlin Everywhere events in 75 countries around the world. And Kotlin just won Breakout Project of the Year at OSCON. If you haven't tried Kotlin yet, it's a really good time to try it. Whatever you can write in the Java programming language, you can write faster in Kotlin with less code. You have fewer bugs. There's full null safety built in, so no more null pointer exceptions. Idiomatic data classes, code routines for asynchronous code, which is super key for mobile apps. And all our benchmarks show that an app written in Kotlin is just as fast as an app written in the Java programming language. Because Kotlin is fully interoperable with the Java programming language, you can mix and match the two. So you can start using Kotlin in just a class or just a new part of your app. That's also what we did at Google. There are several major apps that are already in production: Drive, News, Nest, Playbooks, Google Home, and even more are coming. We're committed to making Kotlin better for the long term, and we're partnering even closer with JetBrains to do that. Faster Kotlin compile speeds, incremental annotation processing with KAPT, better IDE typing latency, more lint checks, and even optimizations in R8 that are aware of Kotlin-specific bytecode patterns to make your app sizes smaller. And today, we're releasing full IDE support for Kotlin build scripts. We are growing a global community of modern Kotlin developers. If you're just starting out and just learning, wouldn't it be cool if you could learn Kotlin today without downloading any tools? You can with the Kotlin Playground by JetBrains or the new Kotlin Hands-On. If you're looking to grow your skills, we have a number of courses on Udacity, and we're also launching a new advanced Android course. If you want to test your skills and you want something to prove for it, we're offering an Android developer certification with Kotlin. It normally costs $149, and if you're watching on the live stream, you'll get the code to get it for $99. If you're with us in person, we're giving it to you for free. And one more thing, if you think that you're ready to be a Kotlin expert and you want to join our extended team, we're expanding the Kotlin Google Developer Expert Program, which is sponsored by Android, Google Cloud, and JetBrains. And it means you'll have even closer interaction with the engineering teams at Google and JetBrains. We are having so much fun with Kotlin and Jetpack, and I'd like to invite Roman to tell us more.
The introduction of Jetpack marked a huge shift for us. We're investing in crafting an API layer on top of the foundations the Android team has been building for years to help you build high-quality apps more easily. Jetpack can now be found in over 84% of the top 10,000 Play Store apps, and 70% of pro Android developers use it. It is designed to solve real-world issues that you face every single day. And to that effect, we've expanded Jetpack significantly, and we're now offering over 70 libraries, from architecture components to Kotlin extensions to camera and a lot more. But I would like to share with you some of the progress we've made over the past few months, starting with benchmarking. It was first unveiled at Google I/O and is now available as a release candidate. This library makes it easy to measure the performance of your application with confidence, and we even use it ourselves to measure the performance improvements and regressions of several Jetpack libraries, including Jetpack Compose. View binding is an easier way to access views from your code. It is a type-safe solution with minimal build-time impact. There's no more find view by ID, and there's no more annotation processor. And you can start using it today if you download Android Studio 3.6 Beta 1. Camera X will be available in beta in December. And by addressing the differences between the many devices that are part of the Android ecosystem, Camera X lets you focus on what you do best, building your application. And we already use Camera X in two major Google apps, Google Lens and Lens Go. And those two apps have seen a 10% reduction in camera-related crashes thanks to this library. But beyond core camera functionality, Camera X also offers extensions such as night mode. And many manufacturers like Samsung, Xiaomi, Oppo, Motorola, and LG are committed to supporting those extensions. But the key to the success of Jetpack has been listening to you. And we heard you loud and clear. You love Kotlin, you want simple APIs, you want declarative APIs, and you want state-of-the-art tooling. And that's why a few months ago at Google I/O, we unveiled our most ambitious project to date, Jetpack Compose, the modern Android UI toolkit. Jetpack Compose makes it easy to build beautiful native apps. It offers a declarative way to build UIs. It makes your code simpler and more intuitive. And we're inspired by Kotlin. You can adopt Compose at your own pace, thanks to seamless compatibility with the existing UI toolkit. But let's take a look at a demo. So here I have a simple app that I'm trying to write. It's a photo gallery. I want to show a list of my photos. There's not much yet on screen, so let's write it. You can see here in my activity, I already wrote a photo card composable function. So a composable function is a component. It's a visual component. We're not going to look at this one just yet. But before I write the actual UI of the app, I want to make sure that my photo card works correctly. And the best way to do this in Android Studio is to create a new composable function. This is a preview, so I have some test data that's already there. I'm going to add a material theme scaffold, just to make sure I have the proper colors. And then I'm going to invoke my component and give it my test data. And if I use this new preview annotation, I'm going to give it a name. I can just hit build and refresh. And in just a couple seconds, you're going to see a preview of the component right there in the IDE. I said a couple seconds. All right, here it is. But what makes this really powerful is that you can create as many previews as you want. So for instance, if I create a second one and I change the theme to be the dark theme, I can just hit refresh. And then I'm going to see two previews with the two different themes right here, again, in the IDE. And of course, I can change the test data. I can refresh again, and you're going to see the bottom card update with a different photo. So let's build the rest of the app. So I want a list of those cards, so I'm going to use a vertical scroller. It's going to contain what you know as a vertical linear layout. We call that a column. I'm going to add some spacing around it to make it look pretty. And the beauty of this declarative model is I have this list of photos as a parameter to my composable. And all I have to do is iterate over it like you would in any other place in your code. And for each photo, I'm just going to add a photo card and some extra space at the bottom. And now I'm ready to run the app. But I don't know about you, like going back and forth between the IDE and the emulator can be a little annoying. So I just want to show you something that will come to Android Studio at some point in the future. It's the embedded emulator. So now, of course. It worked yesterday. All right. Let's fix it in real time. No, wrong tab. This tab, this tab. No. All right. All right. We're going to try it one last time. Wrong version of the emulator. There we go. All right. Let's see if it connects this time. View, tool window, emulator. No. All right. So of course it worked in every rehearsal. You would see the emulator running side by side. So this is really powerful because it's fully interactive. So you could see the real app running, next to your previews that are effectively your unit tests for the composable next to your code. All right. So Compose is a lot of fun to work with, but until now, if you wanted to try it, it was a little difficult. You had to download several gigabytes of source code, and you had to build everything yourself. And I know you're not used to it. That's what we do every day. So it's painful, but we're aware of it. So today, to make your life easier, we are releasing the Jetpack Compose developer preview. All you need to do is download the latest Canary build of Android Studio, and you'll be good to go. We've also added a Compose section on developer.android.com, and it includes a beautiful tutorial. We also have sample apps that you can see on screen that have been built with Compose. It gives you an idea of the support we have for material design. And Compose marks another drastic shift for us. It is developed entirely in the open. All the work happens in AOSP. And the team engages in daily discussions with the community. We're present on the Kotlin Lang Slack channel. You can join us if you want. And we also run monthly developer studies. And thanks to all the feedback that we're getting continuously, we've already made many, many API improvements. So I would like to thank all of you who have been helping us and supporting us. Things are only getting better thanks to you. And because of that feedback, our current plan is to ship Jetpack Compose as a beta next year. As you just saw in the demo, when it works, Compose works is designed in close relationship with Android Studio, but I will let Karen tell you more about the IDE.
Thanks, Roman. I am personally really excited about Compose. But one of my favorite things about Compose is that there's full Android Studio support. Android Studio is the official IDE for Android, and we've come so far since our 1.0 release. It has full support for Windows, Macs, Linux, and also Chrome OS, with Chrome OS app usage growing 4 times in the last year. So the team has been working on way more than just Compose, and I want to show you some of that. So we want to make iterating on code faster, doing things like the preview or the embedded emulator, doing things like apply changes, creating faster deployment speeds, or even showing a preview of Chromebooks where you can deploy your app directly onto a Chromebook so you can test and develop on the same exact machine. We're also looking at existing pain points, and we've heard that animation is hard. We've heard that looking at resources is hard. So I'm going to pass it back to Roman to show you a little bit more about some non-Compose stuff.
All right, because before I get to the fun bits, I just wanted to show you a Gradle script written in Kotlin. And of course, you have access to the full power of the IDE, so you have code completion. Go ahead, code completion, you can do it. There we go. And you have quick fixes. All right, so this is the visual editor using constraint layout. If I click on the widgets, if you're familiar with constraint layout, you know this is what you expect. And we have this panel that we want to open from the bottom, and we want to animate that. And you all know that sometimes doing animations on Android can be a little challenging. First, you have to choose which API to use. So we decided to make it easier in the tools. So if you have a constraint layout, you can just right-click on it. You can click Convert to Motion Layout. We accept. And now you can see that we have a start and end state. And from here, what you would do is you would change the position of your widgets in the different states. You can create your own states. And from that, we can create animated transitions. So I'm going to switch to a different files where I've done most of the work. So you can see my start state where everything is collapsed. You can see my end state where everything is open. But you can animate more than just constraints. If you look at the color of the app bar and the fab, you can see that they change between the 2 states. And now if I select this transition arrow, I can play the animation right here in the IDE. And I can even scrub back and forth, so it makes creating animations a lot simpler. So another thing I want to show you is right here. So I'm going to run this app. The app itself is not super interesting. What's interesting is this new live layout inspector at the bottom. So it just connected. And you can see that when I play with the app, if I change the screen, the inspector updates in real time. And of course, now it's stuck. OK, here we go. I can select any of the views, and it's going to select them in the hierarchy on the left. You can inspect all the attributes. If I select the submit button, it does something that I find awesome. Look at the text size. It says 50. And we all know that themes and styles are a little complex, and sometimes it's hard to know where the value comes from. So if I expand this, it's going to tell me it comes from this fragment. And it came from that dimension value. And you can see that we're overriding the original value of 18, which is defined in the style and the theme. So you won't have to spend hours anymore debugging themes and styles. Before we go back to Karen, can we switch to the other demo machine, please? I fixed the demo. All right. There you go.
Thanks, Ron. That was great. So it's just as we talked about seamless compatibility with Compose and how you'll bring it with your existing code, the same tools team is working on both. So a lot of what you saw here is going to work in the Compose world. So we know that the IDE, though, is where you spend all your time. So if the IDE is hanging or your builds take too long, it doesn't matter how cool a feature is. I heard you loud and clear. Make our IDE rock solid. We spent 8 months on Project Marble, focused on stability, performance, and fundamentals for Android Studio 3.5. We saw double-digit improvements, 60% drop in UI hangs, or freeze times, 40% drop in UI hangs, over 50 memory leaks fixed, 23% drop in Gradle sync failures, and a 57% faster deployment speeds. We took the time to get some features that we didn't get right the first time, like Instant Run. We rebuilt them totally from the ground up. We relaunched them as apply changes, and then we deleted over 50,000 lines of code. And we know that we're not done yet. We're committed to a focus on quality, and we built the infrastructure and the dashboards that we needed to keep getting this right. OK, let's talk about build speed. It's been the #1 request for the last 5 years. We kept chipping away at build speeds, our Gradle build speeds, but total build times weren't getting faster. Code bases were getting larger, Custom plugins were adding to build times. Incremental annotation processors were negating the benefit of incremental build. So we broadened our focus, and we tackled the top annotation processors. Glide, data binding, Dagger, they're all incremental now. And we didn't stop there. Resource processing, multi-module dexing, generating only a single R class, they're all faster. And those average build times, we're seeing 24% drop, and they're improving every release. And finally, we're helping you spot issues in your own builds by helping you visualize what's time spent across the build pipeline, so you can see if it's a custom plugin, if it's build configuration, and then choose what to do with your own build. Okay, just moments ago, we released the first canary of Android Studio 4.0. It contains the preview of our compose tooling that you saw with Roman. So that live preview, the code completion, a full sample, it has some project templates. It's way easier to try out compose. It has Java 8 library desugaring. It has the motion editor. It has full support for KTS files and Kotlin live templates. And now I'd like to invite Tien to tell us more about modern distribution. Thank you.
Hi, everyone. I'm Tien, and I run product and UX for Google Play and Android App Safety. Today literally marks my 2nd anniversary at Google. In that short time, I've met many talented and creative developers around the world. And it's been especially inspiring for me when I visit markets like Brazil or Nigeria and meet developers who've been able to build global audiences or build businesses that solve real local problems. As you heard Dave mention earlier, user privacy is foundational to what we do. If users don't trust Android and Play, then there won't be anyone to download your apps. Trust and safety has always been a top priority at Play, with human reviewers, constant improvements to Play Protect, and policy updates to evolve with the threats that we see. As a result, apps that are downloaded from Play are an order of magnitude safer than from any other source. This year, we've been increasing all our detection capabilities for impersonators, repackaging, bad content, and other forms of abuse. But we know there's a lot more that we could be doing. We've seen SDKs that seem well-behaved, but later try to do nasty things like enlist a user phone into a botnet or exfiltrate personal information. We're up against some really sophisticated bad actors, but I'm also very proud of the way that we've taken action. With your help, we've reduced access to sensitive data and made Play even safer for children and families. We restricted SMS and call-out permissions to only apps that need them as part of their core functionality. As a result, 98% fewer apps now access the sensitive data. This is thanks to your hard work. Users are now safer, and they know they're safer when they download apps that request fewer permissions. Now, to help protect children and to give parents more confidence when choosing apps for their children, we updated our families policies. They're more stringent with regards to content, ads, and PII. And we're asking you for more information on who your app is for so we can better surface the right content to the right age groups. We're not stopping there. We're working with teachers to better identify quality apps for children. We're working on rules to ensure users understand their subscriptions. We're working to ensure developers access background location data appropriately. And we're working on better protecting your intellectual property. We're also starting to work with SDK providers to help them improve their quality and help app developers know which SDKs are safe. Just to give you an idea of the scale at which we have to operate, we recently took action against a malicious SDK. It affected 200,000 apps. As you can imagine, it's kind of hard to reliably reach out to 200,000 developers. Now let me pause there. I know that's a lot of change. And changes like these are really hard to make gracefully on such a large ecosystem. We understand the burden that it places on you to have to constantly adapt to new policies. especially when the vast majority of you have done nothing wrong. You've told us that our change process could use some work, that our communications are too vague, impersonal, or that you might have needed more time. That is absolutely on us to fix, and I promise that we will continually improve in this area. Now, I get a lot of questions about app reviews and developer bans. I want to give you a sneak peek behind the curtain. Every day, we have humans reviewing 30,000 new and updated app submissions. Even though some of the more complex reviews may take up to 7 days, most apps are reviewed within a couple. And as always, all appeals are reviewed by humans. Now, developers that repeatedly break policy are banned from play. These developers use many tactics to get new accounts and try again. Our systems are really good here. The vast majority of accounts are banned correctly, and many are banned before the bad actor has a chance to publish. Sometimes we get it wrong, though, and we know that those rare cases are super painful. Any developer ban can be appealed. It'll be reviewed by our global team, and if a mistake is found, they'll be reinstated. We'll continue to improve here. We're also working to include more useful detail in the Play console, with information on the status of app reviews, policy changes that might impact your apps, and other critical information. So look for some big changes in the coming year. We have to keep our users safe. It's in our shared interest. It's the only way we're going to keep this platform growing and thriving. So please keep working with us. Please keep providing feedback and help us through this period of change. Now, let's talk about some of the ways we're helping you reach users and build your businesses. It has been 18 months since we introduced the Android App Bundle as our vision for the future of app distribution. Over 250,000 app bundles are now in production, covering 25% of all active installs. Developers that switch see pretty substantial decreases in app size, and as a result, some have seen an up to 11% uplift in installs. Based on your feedback, we're making app bundles and dynamic delivery much easier to test. Internal app sharing lets you test builds of your app bundle as easily as you share APKs. And what's cool is that you can grant anyone on your team access to artifacts without giving them console access. We're also making it possible to get download links for old versions of your app, whether they were bundles or APKs. Finally, a lot of you have been asking for this. We're launching offline testing of dynamic delivery today with the Fake Split Install Manager. Another way that we help developers is by helping them launch successfully. From beta testing features to technical quality testing to staged rollouts, we have many features to help you take your idea to market. Recently, we've been focused on creating demand. Pre-reg is a best practice for building excitement around your app or game. We launched to general availability at GDC, and many developers have been using this to great success. Based on your feedback, we've been adding features to the program. A couple of examples. Nexon, a Korean dev, used pre-reg rewards to offer users 300 diamonds for pre-registering. Players who pre-registered had almost 50% higher day 60 retention and 70% higher ARPDAU. Edermax, a Brazilian dev, ran a pre-reg campaign with milestone rewards, with 4 milestone levels, each unlocking a unique in-game item. And users who pre-registered played 30% more daily minutes. We also just finished another successful launch, a little title you may have heard, Call of Duty Mobile. That saw almost 60 million installs in the first 10 days. With our new store merchandising capabilities, we were able to build hype all over the world and drive tens of millions of pre-registrations. We actually also worked directly with them to enable custom beta groups so they could test their game on specific devices in specific locales. This exclusive beta program is something we hope to scale out to more developers real soon. Another long-term bet for us is Play Pass. At $4.99 a month, users get access to hundreds of awesome apps and games completely free of ads and in-app purchases. I'm personally incredibly excited about this. I've been in the games industry for more than 20 years. I've shipped game consoles and games. I know the industry needs to have business models that work for all kinds of apps and games. Android has more reach than any other platform, and I want it to be a place where creative indie breakouts and shorter story-based games can be successful alongside free-to-play juggernauts or innovative apps. PlayPass only succeeds if developers succeed. So we'll be doing that by compensating developers fairly for the value they provide to the users, whether it's a daily diary app, a short game that can finish in a few hours, or a game that you might be playing for weeks on end. We'll be using many signals to reward developers fairly, and we'll continue to tune that model and curate the best possible catalog for users. We've been working on PlayPass for a few years now, and I wanted to thank the hundreds of developers who joined us for the initial offering. Now, I'd like to invite Steph back up to talk about the platform. Thank you.
All right, so we've talked about tools and APIs, we've talked about Play. What about the operating system itself and what's coming? Now at I/O, this would be the cool new stuff for users part of the keynote. But today is Dev Summit, and it's all about developers. So I want to share with you important things you should know about how we're evolving OS releases with a developer lens and information to help you prepare and take advantage of what's coming. First, I want to give you a glimpse in some of what we're working on for the operating system, a focus on how it impacts developers and some recommendations for how to optimize your apps. Second, I want to talk about a new way to get involved in where the platform's going. And third, I want to talk about release schedules. No dates, but key developer milestones and how we can think about each one so you can plan ahead. So let's start with what we're working on. You heard from Dave, you heard from Tian, security and privacy is a foundational commitment across Android and Play. And what's happening here is really important for us as developers. Now, Android's leading in everything from industry reports like Gartner to Zerodium announcing they'll pay more for Android exploits than any other mobile OS. But privacy and security is not one feature or moment. It's a continuous commitment and investment. I want you to know you should expect to see more protections coming. That's why we decided to preview here at Dev Summit. We'll have 4 dedicated sessions, so you can preview OS enhancements to permissions, storage protections, connected devices, and one more thing. For users, these give more transparency and control. For developers, they should be straightforward to implement. Your feedback on features like scope storage in Android 10 was fantastic. And learning from this, what we want to do is share this kind of information earlier than ever. We want to explain our reasoning, we want to get your feedback, and then give you as much detail as possible so you can plan ahead. So second, I want to talk about a new way that you can get involved. Dave talked about helpful innovation as one of the new work streams shaping the future of Android. On-device machine learning and federated learning are driving incredible breakthroughs, like the live caption that we talked about earlier this year. For the 500 million people who are deaf or hard of hearing, something like live caption can bring content to life. Now, these are the kind of innovations that we want to invest in. And we thought about it and decided we want to do this together with our developer community. Over 10 years ago, we announced our first Android Developer Challenge. Today, modern Android is shaping a next-generation platform. And so it seemed kind of fitting to announce the Android Developer Challenge is back. And the first Android Developer Challenge we're announcing will be helpful innovation and machine learning. We're asking all of you to submit ideas. We'll pick the top 10. We will then bring those teams to Google. You will meet leading experts in machine learning and Android from across the company. You will get an exclusive look at Android 11. And once your apps are ready, we'll share them in a collection on Google Play for billions of users to see. And yes, you will get insider tickets to Google I/O because we'll bring the teams back to Google I/O to showcase your work. So we're very excited to see what you build, and I hope you join the Android Developer Challenge. So finally, I want to talk about how we release Android's operating system. Now, we've been rethinking this in order to make it better for you. What I hear from developers is, operating system changes have a huge impact on developers. And it's great that the platform is evolving, but you want to see us be very careful to minimize developer impact and also get insight into schedules. So here is a look at Android's new release schedule. For the next OS release, developer previews is where we'll begin. And this is because we think everything starts with developers. It's the best way we could think of to give you the advance notice and the time that you need. We started the previews a few years ago, and they have been great. So here's the point where we'll be actively adjusting APIs and features. Now, during developer previews, you should be kicking the tires and filing feedback. We'll give you a public release to flash your device, updated developer tools, and crucial docs. OK, then comes beta. Now, beta is when usage grows dramatically. In Android 10, we had 21 devices from 13 OEMs, and users can easily enroll online. And all of this means a lot of users. That's why at Beta 1, you should test and convert your app. Now, we thought about what we could do to help, and we decided to commit to giving you something we're calling a stability milestone, a close to final SDK by then, as well as the tools you need, including emulators and more. We're also committing to close to final APIs so you can convert efficiently on a stable platform. We'll move to API freeze and final SDK shortly after beta. Now, there may be a few exceptions to API freeze, but expect us to share those as fast as we possibly can. We've also recently added a new app compat feature to the Play console to help you analyze and migrate. Now, after beta, we move to RC and final release. And the final release every year is when we'll bump target SDK. The SDK target requirement is N-1. So that means at Android 11, you'll target Android 10. This is designed to give you a year's notice. And wherever possible, we want to place developer impacting changes behind target SDK. The goal is to move Android forward together while giving you the maximum time we can to adopt. So, OK, let's wrap up. That's been a quick tour of modern Android and the road ahead across our developer experiences, Play, and the platform. I really hope you download and try everything you heard about today, from Android Studio 4.0 to Compose and more. And we are very excited to have you here at Dev Summit today. Our goal is to share as much as we can of everything you need to know about Android. There'll be nearly 60 sessions. There are 100 speakers. We'll cover modern Android development from Compose to Kotlin. You can learn more about modern distribution. And we'll deep dive on platform changes, including things that are in the works in important areas like privacy. At the Sandbox, you will find over 250 members of the Android team. They're all here to meet you. And you can find out when your favorite team will be here just by looking in the Dev Summit app. The live stream will cover everything that happens on the main stage, plus interviews and more. So I'd like to thank you for your time today and ask you to enjoy Android Dev Summit. Thank you.
Okay, and I think we're live. So hello, welcome to the Android Dev Summit 2019 and very first ever Ask Android livestream. I'm Lila Fujiwara, and I'm an Android developer advocate.
And I'm Dan Galpin, also an Android developer advocate, and I'm Lila's manager. Which means I'm ultimately responsible for everything that I say and everything that she says.
Yep. All right, so let's get to it. Also a bit long, the hashtag AskAndroid team will be answering your questions on form factors, Jetpack Compose, Kotlin, coroutines, CameraX, community, architecture components, Android 10, and so much more.
How about tools? Yeah, Android Studio.
And tools, which is happening right now.
All right, so if you already have a burning question or you're excited about something you saw in the keynote, well, there's no need to wait. Tweet at #AskAndroid for a chance to see your questions answered live during the Android Developer Summit.
And you can also put your questions on the live stream, so either way. Okay, so finally, a big shout out to everybody that's participating on the live stream from around the world. I have a few countries here. Bangladesh, welcome. Kenya, Congo, Brazil, Indonesia, Germany, Netherlands, Pakistan, India, Nepal, Mexico, and the faraway land of Palo Alto.
We have a jam-packed show for you today, so let's get rolling.
All right, so first up, I think we already got a sneak peek, but we're chatting with Chet and Tor.
Now, in that order.
Yes, Chet and Tor.
So Tor is the tech lead for Android Studio, and he's our demo master, while Chet leads scalable outreach for Android after a long stint leading the toolkit team and is an expert in graphics, UI, performance, and donuts. You can catch both of them regularly on the Android Developers Backstage podcast, which means they both love to talk. So let's, welcome Chet and Tor.
Okay, so go ahead and start asking your questions. We got one right off the bat. So keynote just happened. What was the favorite thing that you saw from the keynote?
I like seeing more about Compose on the screen, seeing a little bit more code and how stuff is put together.
That's it.
Well, I figured you were going to hour-long.
How it's composed.
You can add the other part of it, which is, but what about?
Well, clearly Android Studio 4.0.
Okay.
Right.
So you're going to talk about the tools for Compose. You're like, what is Compose without the Android?
Right. It is one of the many features in Studio 4.0. So we actually bumped major versions, right, from 3.6 to 4.0, and it's because we have a lot of awesome features. Compose is one of them, but there's many other things as well.
All right. So both of those things, if you want to check them out, you have to download Android Studio 4.0.
That's right.
All right.
Yeah. And people can play with the motion editor, is that true?
Yes, I think the motion editor is enabled in Canary 1.
Wow, that's exciting. All right, so we have a question from Andref Sousa, which is pronounced something like that. Is there a way to change the default Android emulator phone number and country code?
No.
That's a good question. I like that.
I asked the team. There isn't, and their question was like, why do you want that? So, if it's a
So when you tweet back at him, why do you want that?
They know this is not like a back and forth conversation, right?
Well, it's more, if we add a setting for every possible one user request, it will be kind of a mess of a UI. So we try to make sure that there's a really good use case for it. So if someone would make that case, then we would consider it, of course.
But I mean, mess of a UI, to me, that describes ADT.
Okay, so next question. Sorry with the names. Okay, so Hatorix asks, when are you planning to have a stable version of ViewPager 2?
Good time to ask that question. So it has been, it was alpha for quite a long time. It's been in several beta releases, and the hope is that it goes RC real soon now, which means exactly that, real soon now. And then at RC, the expectation for RC in general is that is basically the stable build, but we want one last sanity check, so I would expect stable to fast follow sometime after that.
All right, sweet.
Okay, so we've got some questions that are coming in from the live stream. Any app security measurement tool coming in Android Studio?
Generally, we don't talk about future plans that we haven't announced.
Oh, okay, there we go. So maybe, maybe not. That was from Amar D.
I have no announcement at this time.
That's a very secure way of putting that. I like that.
The advice that I tend to give in the fireside chat, which we're going to have another one of this afternoon, is if your question has words in it like, will you, or is the team going to, or will there be a feature, like, it's not something, you're not going to get joy out of the answer to that question.
Okay, so with that in mind, Jonathan CPS asks, are you guys working on a tool to show a preview screen for Jetpack Compose?
Yeah.
Yes, so I guess that question was submitted before the keynote because we just gave a demo of it. And so yes, preview is one of the core features of our Compose tooling in Android Studio 4.0.
All right, cool.
Okay, so here's a question. What is your favorite feature in Android Studio 4.0?
Can I reinterpret that to what are your top 5 features in 4.0?
Yeah, absolutely, please.
Because it's very difficult to choose one, plus I'll probably make some enemies on the team.
I was going to say, well, plus this way you can actually pitch multiple features to our audience. This is great.
Exactly. So in my top 5, the first one I would say is the build profiler, which we didn't show in the keynote. So there's going to be a demo later today, but it's basically going to let you see, profile your build to find out what your potential mistakes are, and how to optimize it to run faster.
So I assume, just to get a little more information, I assume that builds on what we've been seeing for a while, which is as it's doing builds, it's actually telling you how long it took to do each of those steps, right? So you're just getting this in a more visual way.
Yeah, but it's not just about showing how long each task took. We are looking, for example, we've instrumented more stuff into the build system, and we're looking for potential mistakes. So we can tell you, for example, hey, this task is, not is always running. It's not looking at its inputs. So that means that it'll always run even incrementally. So we're basically pinpointing a lot of analysis saying, here's a problem, here's how to fix it. So build attribution is one, motion editor is another one. You saw that in the keynote. It's a pretty great feature that people have been waiting for. Compose tooling, of course, is there. My second most favorite, I would say, is having the embedded terminal, the embedded emulator. So we had a little bit of a slip up in the demo in the keynote, but it's a really great feature, and it's just so much more convenient to be able to have the emulator participate in the window management of the IDE than having to sort of juggle top-level windows.
Yeah, I have an emulator that opens up on like a separate screen a lot of the time. So
and then layout inspector, which is has a lot of new features for. It's a bit like the Chrome DevTools, where you can sort of track down why is this font size the way it is, or what is the paint hierarchy looking like? Why do I have a clipping bug?
Yeah, I like the 3D thing. We saw a little bit of that in the demo in the keynote, right?
Yeah, and there's more as well. So we're going to do a 25-minute demo later today of a bunch more features in 4.0.
Awesome. And while we're still going, if you have questions about any of that, please post them to the live stream. Speaking of which, Nor from the live stream asks, is Kotlin good for enterprise?
Of course. Yeah, actually, I gave a talk about Kotlin, just Kotlin language in general, at a conference a few weeks ago, and it was a conference with mostly non-Android developers, and the room was packed. I would say probably a quarter of the people in the room were doing Android development. The rest of the people were using Kotlin on the back end. Enterprise, web, whatever.
And of course, I use Kotlin on the desktop, right? So Kotlin is not just for Android. So Android Studio, we have a lot of, basically almost all the new code we write is written in Kotlin as well, which runs on your desktop.
Awesome. Yeah, and we actually have a Ask Android segment about Kotlin and coroutines that's coming up later. And the person who's basically helping organize Kotlin everywhere is going to be a part of that, so we can answer much more of those questions.
Yeah, so we got another question with the live stream, comes from Lulama. Has Android Studio improved in terms of speed?
I think clearly yes, right? So we spent the last year or 9 months working on something called Project Marble, where we focus exclusively on performance and stability, right? So there's many aspects to speed. I mean, if he or she means build speed, okay, obviously we're working on a profiler. But the things we did in Project Marble was reducing UI freezes, reducing memory usage, optimizing the way we were handling a bunch of calculations. Overall, speed was a big concern for us.
There was some specifics called out in the keynote as well, I think in Karen's section, talking about things like, well, incremental annotation processing got faster. Was that part of Marble?
That's build speed, yeah. It was. And I think another one that maybe not so obvious is that Studio is happy if you give it more memory. Most users actually run with the default, which is about, I can't remember, 1.2 gigs of RAM. For large projects, that's just not enough. And so we actually give you suggestions as part of Marble. Hey, you should resize your heap to something bigger based on your machine and your project size. And if you accept that suggestion, you'll actually find Studio running much better.
Yeah, cool. All right, so I was going to do this one.
Oh, this one goes right into that last thing he was saying.
Okay, cool. So from Twitter, Pranay asks, with more and more features getting added to Android Studio, is there anything done to reduce the IDE memory footprint? Which, with each new release, AS is hogging more and more memory.
Requesting.
Requesting. Kindly requesting more and more memory.
Right. Yeah, so I just answered that. We were.
Wait.
So, that's what I thought, yes. All right, cool. All right, so
down
like
to our last
one.
questions. Yeah, so this one this one here.
Yeah.
Okay, so Adrian asked, in single or multiple activity implementation, which one is better?
Tricky question to answer. We are recommending that people move to single activity. So originally, Android was all about multiple activities. You go from place to place in your application flow, and new windows pop up. It's better user experience if you can stay within one activity. If you have deep links, maybe that's a multiple activity navigation situation.
Okay,
all right.
Cool. So I think that we are about to wrap up, but just with Chet and Tor, so thank you so much for joining us. Any last things to say to the live stream?
Hi.
Try Studio 4.0.
Okay, try Studio 4.0.
Check out the Android Developers Backstage podcast and submit your questions to #AskAndroid.
All right, okay. So we're about to jump into, I think, like a 1 minute long break, and we are going to then be joined by Dave Burke and Steph, who are fresh for the main stage right after their keynote address. So please stay tuned.
If you're just joining us, welcome to the Android Dev Summit 2019 and the very first hashtag Ask Android livestream. Next up, coming straight from the main stage where they delivered the keynote address, are Dave Burke, Android's engineering VP and Director of Developer Experience, Steph Cuthbertson. Sorry,
Okay.
I know. You've been not saying it. I actually tried.
All right, so if you have any questions for the keynote or either of these folks, please remember to use the hashtag AskAndroid tag in the live stream. We have somebody who is actively grabbing your questions. All right, so with that, first question.
So what is your favorite announcement from the keynote?
Ooh, that's a tough one.
That is
you
a tough
pick
one.
on your children.
Can I do an umbrella one, like Android Studio 4, I think? Because there's just so much good stuff in there. Like, I'm excited because it's the first time that we actually have Compose easily accessible, right? So you just download it and use it. There's also the style inspector or the layout inspector. I always call it the wrong thing, where you can actually find out why different styles are being applied. That's pretty cool. The build profiler. What am I forgetting? There's just so much. Motion editor.
Motion editor is really
We
cool.
just had Tor and Jet on, so Tor was talking about a lot of this stuff. I think you're pretty aligned.
Remember we had that discussion that was like 2 weeks ago, and you said to me, it was like, hey Dave, I think like there's a lot in this release, and like because we're going to call it 3.7.
That's right.
And
Yeah,
you were like
3.85 or something.
Yeah.
And we finally said, you know, there's so much in here, we should just call it 4.0.
So I think that's the big one.
Yeah. I mean, obviously the announcements around Compose going to developer preview, like that's a very big deal. And I think it would be really exciting to have people try that out and give us feedback. So that'd be probably the easy one. I also, like, there's a bunch of other really cool things in there. I agree with Dave. Little things like the layout inspector, I think really speak to the attention to detail from the team. Like, people have been asking for something like that for a long time when you're coding themes and styles and you're trying to figure out what the heck just happened. So it's really, I think things that are both very big and then small. And, also, I don't know, I'd say I'm pretty excited about the app bundles work too, because that's one of those things where just by adopting it, you get a bunch of goodness by default. Like just making your app smaller, that's pretty awesome.
Yeah, I'm actually really excited about the build profiler. Like that's been something we've been asking for a long time. So that's really, really cool too.
Yeah, that's super cool. Being able to find out like where your build time is actually getting eaten up, and it's really neat.
Okay, so next question, and this is, I don't know, I'm interested to see what your response will be. So, Burhan Rashid 52 asks, why do we have a new Android OS version every year? Can we slow down a bit?
Interesting question.
It's job security.
Do something for all of us.
Well, I mean, the first I would say, more seriously, it's like we got to understand why the question was asked. But I would say, technology evolves at such a fast pace, right? Like, so you've got to constantly keep up with that. And so, for example, we talked today about foldables, right? And so this is actually a really exciting space. And I think if you, over the next few years, you're going to see some pretty amazing devices. It's early, and I think it's one of those things where some folks are like, oh, I see something there, I'm not sure, but it's going to be exciting. And so we have to evolve the operating system to make sure that we keep up with technology or even lead it. I think the question probably gets more to the fact that like when there's a new operating system release, like it can be sometimes effort to update to it. And
I think that's what developers are really asking. Is I think the question is, how can you make it easy for us to adopt and not disrupt us? And I do think that is a really important consideration. It's a big part of why we did something that was a little unprecedented today, which is we wanted to share, look, here's how we think about the platform milestones for people to prepare, as well as starting to talk about things like, OS resiliency and where we're going with permissions. We've never talked about those so early. And the reason is because we want to give people a chance to give us feedback as well as adapt. Because I think it's a question of both being very thoughtful about any breaking change, keeping them to an absolute minimum. I think of it as few as possible and no less. Because as Dave said, there is also, with the evolution of foldables, what's happening with machine learning, like the platform is going to evolve, and that's a big part of why we love Android. It's just about finding the right balance.
The only constant is change. That's basically what's happening here. But I think that's exactly right. And we spend a lot of time on app compatibility. That's our phrase for like making sure that we haven't broken anything, right? And we're getting better at it. I'm not going to pretend we're perfect at it, but we're getting better at it and putting more effort into that. But it's a great question.
So another question we have is from Puneet99. What is Project Mainline, and how is it different from Project Treble?
Okay, so it's they're orthogonal in a graphical sense. So Project Treble was all about putting a horizontal line between the hardware-specific code, and when I say hardware, I mean silicon-specific, so what SoC you have, and then like the peripherals that your particular device may have. So it's a horizontal line between the hardware-specific code and then the operating system code, and that was one of those things that ideally, when we created the operating system, like in 1.0, you would have put that in place, but Android was moving so fast, and it wasn't worth doing. It was better to go quickly. Later, we put this foundation in, and it means now when a new version of the operating system comes out, it will work on the older code from the hardware, and it just allows developers to move or device makers to move much more quickly. And you saw that with the beta program for Q, Android 10, where we had like 21 devices from 13 OEMs, right? So it works. Mainline, think of it as, and this is why I meant orthogonal, think of it as vertical lines. And so they're like pieces of the operating system on top of Treble that you can then slice out and then update. And I'm excited about, so they're complementary. I'm excited about Mainline because it means we can take sort of, I would say like boring parts of the operating system, like cryptography, which, there's some cool math there by the way, but it, boring from a typical developer, you just expect it to work. And so I think this allows us to basically update those components and have uniformity across different devices.
Okay, and I think we are literally just about out of time. So I want to, we have a little bit of time to really thank Dave and Steph for coming on and talking to us, talking to all of you. Is there
any last thing you want to say to the live stream?
We should
so much.
So much. We talk about
very short last thing
I want to talk about. Thank you for being here. I think I mostly would just be wanting to say thank you so much to everyone for being a part of Dev Summit, for all the feedback. We're really grateful.
Yeah.
All right, well, that concludes this portion of the hashtag Ask Android live stream. Our next speaking session is about to start, and another Ask Android will follow. So next time we'll be answering your questions about Jetpack Compose.
All right, so remember to post your questions. Bye.
Thank you.
Good morning and welcome to What's New in Jetpack Compose. I don't know why it's called that because this is not really what the talk is about. It's more what is Jetpack Compose. Anyway, I'm Romain Guy. I manage the Android Toolkit team at Google.
I'm Clara Vallarri. I'm a tech lead on the Toolkit.
And I'm Adam Powell, and I'm also a tech lead on the Toolkit.
And the Toolkit now is also Jetpack Compose. My clicker, I need that. All right. So what is Jetpack Compose, the real title? So according to developer.android.com, Jetpack Compose is a modern toolkit for building native Android UIs, and it simplifies and accelerates UI development, blah, blah, blah. So in Kotlin. So instead of trying to tell you what it is, I think it's more useful if we try to tell you what kind of problems we're trying to solve, what kind of goals we're trying to achieve with Jetpack Compose. We did some of that, and look, it's me again, same shirt, same pants, different watch.
Consistency, it's good.
Yes. Adam and Jim were with me on stage, and they did most of the talking, so we explained some of the reasoning, and I wanted to go over other points. The first one for us is to simplify the development, and we all got used to the complexity of Android development, and the complexity can mean many different things. You know, some of our APIs are a little awkward to use, you have to manipulate different files, different languages. So I want to show you an actual example. So that's something that Jim works on the Compose compiler and runtime has came up with to try to convince a bunch of people internally that Compose is a good thing. So the idea is to build a simple app where you have a list of names and you just want to type something at the top and it's going to filter the list. So how would you do that with the existing UI toolkit? You start with a simple XML file. You're all used to that, a recycler view, edit text, linear layout, all that good stuff. Then you need another XML file for each list item in the list. So we already have a couple files in XML. Then you need your filtered list view that's just going to do the find view by ID, find the edit text, set up the listeners, find the recycler view, set up the adapter. I'm not even showing the activity here. Finally, you need the adapter itself. So actually, it's funny because when I put that on the slide, I'm like, wait, is that the best way we have to filter a list? So I Googled it, and turns out, because I did write some of the filtering APIs for adapters, so I thought there was a better way. It turns out there's not really, and there's a lot of blog posts, articles, and even Stack Overflow questions on how to do this. I'm proud to announce that this is one of the simpler ways. And then you can use RX Java or fancy frameworks to make this happen. Anyway, that's a lot of code. It's annoying. It is not simple. So this is the entire Compose version. All the code you need is here on screen. Much easier. It's going to be a lot easier to find bugs. And more importantly, when you read the code, it's pretty obvious what the intent of the code is. Like whoever wrote that code, what they wanted to do. So you say, I want a scroller. I want a column of text fields. I want a column with a text field at the top, and for each row, I want an image and a piece of text. And as soon as you change the content of the list, the contact list, everything updates as you would expect. Another thing we want to do is fix what's broken. So that's our API regrets. We talked about this at Google I/O. I invite you to watch the talk if you want to know more. We had a few funny anecdotes. One of the good ones, of course, is Vue.java that now clocks at around 30,000 lines of code. Sure, there's a lot of comments in there, but still.
I think it's down from some point.
Yeah, but still, it's a lot. So the problem for us is, also we have a lot of baggage and history. So there are things that we just cannot fix. We know there are problems, but we just can't fix them. We could introduce new bugs, or apps might be relying on the current behavior. So we're kind of stuck. We can't really do much more with the existing UI toolkit. We want to stop cheating. This is something we did originally, and I think Adam recently, you said on the Kotlin Lang Slack channel that you really, really want @hide to disappear. So if you ever looked at the source code of the Android platform, we have this magical annotation called @hide, which turns public APIs into very private APIs. And super useful to us. It was a way to work around some of the limitations of the Java programming language, but it led over the years, it led to an issue for us. For instance, let's say you want to do something with TextView that TextView doesn't do out of the box. The obvious answer is like, write your own TextView. Well, you start pulling that thread, and then you're grabbing like the entire text package, and you're running to private APIs all over the place, and you can't do anything about it. So that's an issue for us, and that's an issue for us. So what we want to do with Compose is we don't want to rely on private APIs anymore. We kind of have to at the low level to interact with the platform, but all of our widgets are built entirely using public APIs that are available to you. And I'm going to show you actually an example of that.
And the good news is that it's kind of forming a forcing function for us to open more things in the platform itself along the way.
And we have to think a little harder about what we open. Material and animations. I had a pretty heart emoji on the slide. It's gone. Anyway, I like hearts. Anyway, so we want, now we're in the material design world. The existing UI toolkit was built before material design was a thing. So the good news is now we can take material design into account. This is what Clara and her team do in London. And we also are building animations, in strong collaboration with the rest of the Compose UI toolkit. So we expect it's going to be easier and more powerful than it was in the existing one. Tools plus Compose, same thing. When we built the initial UI toolkit, the existing one, there was not that much interaction with the tools team because the tools team was very small. So a lot of the tools came after the fact. So the visual editor, the motion layout that you saw in the keynote. And we want to change that. And you just saw that we're building things like live previews of your composable right now as we're building Compose itself. Kotlin, we adopted Kotlin. We announced that we want to go Kotlin first. So that would be one thing for us to tell you to go Kotlin first. And we thought that maybe it was a good idea to do what we say that you should do. So Compose is written in Kotlin. And Kotlin actually unlocks a lot of the things that we do in Compose. The way we design the API is possible thanks to Kotlin. We rely heavily on lambdas, for instance. And we plan on using fun features like coroutines. Adam is chomping at the bits to add coroutines all over Compose. And finally, compatibility is something that we deeply care about. We are not asking you to rewrite your entire app. If you want to adopt Compose, once it's ready for production, we don't expect you to just delete all the code like we did for Instant Run and to start from scratch. We want you to write your next activity or your next fragment, or to be able to reuse some of your custom views. And chances are that some of the existing views we won't even rewrite ourselves. So things like Surface View or Web View. I don't think, if any of you wants to write a new Web View, like, please come help us, but we're not going to do that. So we're going to use the existing Web View. All right, and finally, this is what the technical stack of Compose looks like. So on one side, we have the build time stack. So that's on the host, what runs on your machine. So we use a slightly modified code version of the Kotlin compiler. So we work closely with JetBrains. We just added a couple of compiler extensions in collaboration with them. And we use those extensions to enable our Compose compiler plugin. So it's funny because last week, people saw that we had the artifacts on Maven for Compose, and people started using them, and they're like, oh, great, it works. We're like, no, it doesn't work. You need the compiler that we haven't released yet. They're like, no, it works. The reason it seems to work is because the syntax is just pure Kotlin, so it's just invoking functions. It was just not very reactive at all, which is kind of a bummer. Anyway, and so we also have Android Studio, and then on the runtime side, so Compose at the bottom is a runtime that just deals with trees. It knows how to produce trees. It doesn't know anything about UI toolkit. So we could reuse it to do other things than UI. Then we have the UI core, the UI foundations, and finally on top, all the widgets. So that's pretty much it. And now Clara will tell you more about how Compose actually works when you write code.
Thank you. So I want to walk you through, sorry, get your applause. I want to walk you through some of the things that you need to understand to really be able to play with Compose, some of the basic concepts. The first one is composable functions. I know Roman has kind of thrown this term out a few times, but a composable function is just a function. It's a function that takes some input and just decides what UI to show based on that input. So in a way, it transforms your application data into your UI hierarchy. Creating a composable function is very, very easy. So for example, we have this greeting composable. It takes a name as a string, and it just decides to emit a text element that uses that string. Text is one of the components that we will provide for you. It is the equivalent of a text view, so it shows a text on the screen. The interesting thing here is because we have the runtime and the compiler behind us, whenever you change that input to say the name you're going to pass through changes, well, then we take care of figuring out what change, re-invoke the function, figure out what we need to change in the UI hierarchy for you. So at any point, you are just describing what you want to see, and we'll take care of the rest. Say, for example, we want to build a news story. We can actually emit several composables within a composable function. So we can emit, say, a title, subtitle, and a date, and we're just going to build our news story. This is absolutely fine, but you will find you kind of need to have an opinion on how you want your UI to show, because if you just do this, you will end up with something like this, which is not really what you wanted. So this is where concept number 2, layouts, come in. We are building out a bunch of layouts for you out of the box to make sure that you can place things on screen as much as you want. So for example, we can wrap those 3 texts in a column. Column is the equivalent of a vertical linear layout, so we'll just place everything one on top of the other. So then suddenly, this looks more like what we were expecting, right? So we have our title, subtitle, and date. Still, Android developers are used to being able to customize a lot of things. You'll be like, this is nice, but my text is really stuck to the side of the screen. So we can go a bit further, add some spacing. And what that will do is just create the spacing around it that we need to make it look a bit better. So until now, we've built this entire UI just with like one function, right? Going a bit further, like column doesn't just take text. I know I used 3 texts as an example, but we can throw anything in there. So for example, we can just display an image by using an image composable, and then build up our UI in this way. Oh yes, sorry. We're providing a bunch of layouts out of the box. There you go. We have row, which will place things horizontally. We have column, which will place things vertically. Those are easy to understand. We have more advanced things. For example, we've introduced flex, which is, I believe is new to Android. We're building a bunch more. There's a bunch more in there that you can go and play with. And we are working on constraint layout, but it's just not there yet. So look forward to that coming. And then, well, we've built a layout, but really what you want is for us to build components for you, right? So Compose comes with a bunch of built-in components that should make it really easy for you to get kick-started. First of all, we've partnered very heavily with the material team, because we want to make sure material is out of the box, just there for you. So we started creating the material components. They're not all there yet, but the team has already been hard at work to be able to create those beautiful UIs. And we already have things like buttons, checkboxes, and a bit more complex things, app bars, drawers. Some of these pieces are in there. In flux, we'll get there. But you already have the basic pieces to build something like a sample app. So say we want to build this material card, building up on the example we had before with the image and the 3 texts. Well, we'll take the code we've had before. I haven't changed anything. We wrap it in a card, and we can give a card a shape, because it's a material thing that you can choose what your corner should look like. So for example, I want rounded corners on my card. We can style the text to look prettier than it was before with the 3 same styles. And you'll say, here, you're reaching into a theme text style. This looks a bit weird. So let's take a step back to the material spec. So in the material spec, there's a definition of all the typographies that you could define in your app. So how you define all the styling of your entire app. There's a preset amount of text styles that you could use, just like they have a color system and a shape system. We've built this out of the box for you. So if you buy into the material system, we have a material theme composable that allows you to configure all of the colors, all of the typography, all of the shapes you need for your app. And then when you put this in your hierarchy, any other material component you're using will know how to read all these values by default, so you don't have to actually style them. Similarly, you can reach into these values, and that's what I'm doing in this example. So I'm saying, out of these 3 texts, I'm reaching into the style and saying I want H6, subtitle 1, and body 1. And it's a very easy way to style if you've set up all your styling for your app correctly. And finally, to finish the app, I can add a row with a couple of buttons. Again, we've provided the material implementations of buttons. So material defines 3 different kinds of buttons. There's contained, outline, and text buttons. And you will find that we keep the same terminology to make it easy to find things. So we have contained buttons, outline buttons, and text buttons available. So all of the material components we provide, we've built purely on the public API from layers below us. So Compose UI Core provides some foundation for us. And we've built everything layered up on top of that. So we've tried to not cheat with any private APIs. This means that Material should be a showcase of how you can build components. We're hoping they're samples, right? Like, they're very useful components, but at the same time, it should be code that you can go in and read and see how we've done it and take those examples for yourself. We've also tried to break everything down into multiple layers, because you can break everything into more and more functions to make sure there's as many reusable bits in there as possible for everyone. And as part of that, we've created this foundation level in the middle. The main idea there is there's a lot of material that is not necessarily design specific. There'll be a bunch of gestures, accessibility that we've implemented to do a button. So we can put the actual button in material, but then we can put the internals of the button in foundation. So all the gestures, accessibility, other things that we've built that are not UI, so that you don't have to start from scratch. You can already start from that layer and just build your UI on top. And then no matter how many components we give you, there's always going to be custom views that you want to do. There's always going to be that designer that asks for a very strange thing that we had never anticipated. So in the existing toolkit, you have to extend view. You have to take care of a bunch of things. It's a lot of work to create a custom view. In Compose, it's extremely simple. You just have to create a function. And there's some building blocks that you can do to help you build up that custom view. The two basic ones are draw and layout. So draw will give you a handle into doing any kind of custom coding that you want. Say, for example, we want to do a checkbox. And a checkbox is just a square with rounded corners and a check mark, right? Let me walk you through the code to do this, because it's quite simple. To draw the box, we open a draw tag. We get access to a canvas and the sizes we've been measured to. So we can easily calculate how much do we want our square to be, apply the rounded corners, and then just draw the square. Same for the checkbox. For the check mark, we'll open a draw. We have access to the canvas and the size. We can calculate the 3 points that make a check mark, and then just draw those on the screen. So surprisingly simple. The next part is layout. Of course, we will try to provide as many layouts as we can out of the box. There will be always something that you want to do that is extremely custom. Well, you can reach down into the layout component. I've tried to show here an example. The most simple example I could find is a stack or a frame layout, right? Like stacking things one on top of the other. So you will create a function that takes a bunch of children that it needs to place. We open a layout tag. We get access to these children that are measurable pieces and all the constraints we have. And then we just have to go through 2 easy steps. We measure each of the children to make sure we know what size they want to be. And then we decide what size we want to be. So for example, in a stack, I'll probably want the maximum of the children to make sure they all fit. And then I'll place them each at the 0, 0 coordinate, because that's what a stack would do. So then we'll end up with an effect that is something like this. Hand over to Ramon.
All right, so what we have today. Like mentioned in the keynote, we just released our developer preview. It's called 0.1.0-dev02. So if not clear enough, it is not quite ready for production. But I want to show you some code and a demo. So if you can switch to the demo machine, please. All right. So one of the sample apps we have is called Jet News. You can see it on the right in the emulator. So it gives you a good idea of the kind of things you can already build today. We have horizontal scrolling list, vertical scrolling list. The tech stack is already pretty advanced, so you can do a lot of complex text layouting and styling. So this is a very interesting app to look at. It's not a real app, like it's not connected to a database or web service to keep the sample simple, but it's a very good example of how to create your own widgets and to use the existing widgets. So what I wanted to show you is what you see here. So yesterday, I built this little to-do list app. So I have a little fab icon in the bottom right, and when you click on it, I just want to add list items. And each list item will have a little bookmark icon that I want to be able to toggle. So the way it works here, my data model is a simple data class in Kotlin. Is the text big enough, by the way, on the screen for everyone? All right, I'll assume it's a yes. So we have a data class. It's immutable. Everything's a val, and you can see that an item can be a favorite and just has a description and an ID. Then the actual model for the app is just this empty list of to-do items. And it's going to be an immutable list. And I wrapped it into this object. That's probably not how you would do it in a real app, like using an object like this, a global object. But I use this @model annotation. And the @model basically turns this object into an observable object. So whenever I change the item's property, the UI will recompose automatically, and Adam will tell you more about this. And if you want to know even more details, Leland has a talk tomorrow where he explains how it works internally in the compiler. This is the main part of the application, so very similar to what we saw earlier in the keynote. I have a vertical scroller, I have a column, I just iterate over all the items, and then for each item I create a row. You can ignore the parameters. But I have this bookmark icon, so this is a composable I created. And one of the things I really like about Compose, and that was one of the things we really wanted to do, we wanted to make it easy to create your own widgets. Like very often in Android applications, we end up with very large XML files because it's very cumbersome to create all those XML files, doing the find by ID, doing the includes and the merge and all that stuff. And here, all you have to do is, like, when I first wrote this application, I wrote everything into this items composable. And then when I saw that I had this bookmark icon composable, I just selected it, I extracted a method using a refactor in IntelliJ, and I just added my @composable annotation. And that's all you need to do to create a new component. You don't have to extend from view or view group and override methods. And then I just have a small spacer, and finally the piece of text that describes the item. So the bookmark icon is here, and here you can see another interesting, oops, I'm revealing what I'm going to type. That's my cheat in case I forget what to do. So my bookmark icon is pretty simple. It takes one of those to-do items. It's wrapped by a clickable, so that's how you create a click listener, really. And inside, all I do is I have this branch, and I say, if this item is a favorite, then I want to show the image that corresponds to the favorite state. And if it's not a favorite, I want to use the other image. So it shows you that it's not just about using for loops, for instance, for each. You can use like any kind of control flow you want, and it makes the code extremely easy to read. And you could do this piece of code in different ways. Anyway, so I have two callbacks in the app. I have this toggle favorite when we're going to click the bookmark icon, and I also have one when we click the fab. So I'm going to try to write them. So when we add an item, I'm going to take the list of items, and I'm going to add a new item that I conveniently have in my clipboard. So we just give a default string and an ID. So if I rerun that, and you can note that's all I did, right? Like there's no listener, I don't call relayout, request layout, or invalidate. And when I click the button, a new item appears in the list. And that's all you have to do. And that's thanks to this @model right here, because we observe that the items are changing. But now I want to be able to toggle those little bookmarks. Like when I click right now, nothing happens. So the way I'm doing it is because it's an immutable list. Let's see if I remember. So I'm going to do a map. I feel so fancy when I do functional programming. Let's see. So if it.id equals the item we clicked, ID, return a copy, and I will do favorite equals not to do dot favorite. So I'm just toggling the Boolean. Otherwise, I just leave the item unmodified. All right, that should work. Relaunch the app. So add a few items, and now when I click, it toggles the icon. Yay!
Ooh.
And that's why always be prepared. I will make it work. Oh yeah, use the wrong item. All right, add items, bookmark. Yes, all right, now it works. So again, like the point here is to show you like how easy it is to manipulate your data and to build that logic and make it interact with the UI. And more importantly, like you can keep like both kind of separated or more separated than you could before. But Adam will tell you a lot more about that. Can you go back to the slides, please?
Thank you. All right, so this is the part of the talk where we talk a little bit more about kind of our design thinking behind Compose and kind of what's on our mind. So in addition to the team's ongoing work with Compose, we've also been spending a lot of time talking with the community. Some of you have probably been part of that conversation, as well as running some more formal user studies. And so here are some of the things that are really sort of top of mind for us that we're excited about or that we think is really kind of important as you take it for a test drive. So be careful that some of this isn't implemented yet. This is just kind of how we're thinking about some of these open questions. So please join us in kind of participating in some of the design process. So the first thing that really kind of hits you as soon as you start working with Compose is the data flow. And while some of the tools available for managing that data flow came into Compose very early, or they existed before Compose did in the case of just some of the standard functional and reactive systems that you might be used to, the best practices and teaching materials around all of this is still kind of a work in progress. Like we really are building something new here. So the Android architecture components libraries have been really successful so far, and it set the stage nicely and established patterns that we've continued with in Compose itself. So let's go ahead and distill down some of those ideas and kind of see where they lead us. Next. There we go. So we showed this diagram at Google I/O during our talk on Compose there. Data flow is really kind of the first thing that you encounter, like I said. The shape of the API more or less enforces this top-down one-way data flow approach. It's just functions calling functions. And most people like this so far, so it's always good to have a single source of truth in your UI. And it's kind of frustrating when your views have a different idea about the state of your app than your application model does, which is definitely the case when you're working with views in the average Android app. So what do we mean when we talk about single source of truth in a UI? Well, it's about avoiding conflicts or making sure that you're not showing inconsistent data, but it's also kind of about who has write permissions to that state. So with Compose, you prevent inconsistencies by having the owner of a piece of state pass that state to the other composable functions that need it. So the parameters that we call our composable functions with, they have to come from somewhere, and the source of that data is kind of our source of truth by definition. And the interface that we use to pass those parameters really kind of determines what the composable functions can do with it, just like with any other function. So you see access control layering like this in Kotlin frequently in the standard library. You've got the list interface here, which only defines the read methods, but the methods to actually change that state are defined in mutable list. So even if I have a mutable list, if I pass it to a function like the aptly named doStuff over here, as the read-only list interface, I can be reasonably sure that doStuff isn't going to change my data out from under me. So from a certain point of view, source of truth has to do with who has access to a mutable reference to that source of truth and what kind of mutations a caller can perform with that reference. If you can change the source of truth, or if you can change the truth in any way that you want, are you yourself a source of it? Well, kind of. So we use event handler lambdas kind of liberally throughout Compose because it's kind of a more restricted way to express a very specific mutation that you can make to state without actually giving away the keys in the process. So here's kind of what I mean by that. We can show this just by using views with some of the APIs that you're used to. So here I've just added a click listener to the view, and inside that listener, I'm using the fact that I have access to this myList variable from the example before, and that's our mutable list. So that's in my lexical scope, so I can capture it as part of the listener block and just use it directly. I haven't actually leaked a mutable reference outside of this code snippet. Like, the block where this appears is the only place where mutable list is accessible from anything. I haven't permitted mutation in any sort of uncontrolled ways by giving out a reference to it. So all my view can do is just tell me that a click happened, and I've defined how this higher level will respond to those clicks given this layer's access level. So this is a really simple example, and we're just kind of using lists, and we definitely did so in the demo as well, as sort of a hand wave for, hey, this is the rest of the app model. I mean, clearly you'll be doing something a little bit more sophisticated than direct mutations on lists, so bear with us a little bit. So a more real example might do something kind of like this. So in this sort of sample view binding method, I'm setting a click listener that makes some requests to my app based on the parameters that I was passed when the bind happened. So just like before with the mutable list, I didn't teach buttons how to add and remove bookmarks. I defined what a bound button should do when the button raises a click event. And I used the context that was available to me when I bound it, that's just the lexical scope, to form that definition. So this is all pretty standard stuff, so what's actually new here? I mean, this isn't unique to Compose here. But it's kind of the framing for what comes next, which is that Compose code is really, really dense. Like, we think that this is pretty great that you can remove so much boilerplate, but the trade-off for that is that sometimes the distinctions of what you're really doing become kind of subtle when it's compressed into such a small space. So let's look at the same pattern that we just saw using Compose. In this case, it's not actually that much smaller. It doesn't look that much different. We're declaring the actual button as an implementation detail along with its properties. So what its text is and what will happen when it's clicked, same thing. But the syntax here is kind of interesting. We said before that state flows down and events flow up, but we're passing both text and the onClick handler to button in the same way. They're both parameters. So in a way, event handlers are just another kind of state that flows down. It's a state that the bookmark button created and that it owns. So as far as button is concerned, it's just this opaque token that can be invoked. So when it is clicked, we make a request to this bookmarker object that's not yet defined here to please add or remove the associated bookmark in response. So the bookmarker might be backed by a local database, API calls to some backend, really whatever. I can fake it or test it outside the context of my UI. But I've defined how the UI itself interacts with the bookmarker in one place here, along with the structure of the UI that's being manipulated. So bookmarker can be written to expose whatever operations that are appropriate to its clients like this one. So the single source of truth here is preserved. So that's a single snapshot of that truth. But the real power of a declarative UI framework like Compose is that it can keep up with changes over time. So it'd be really nice if my code was always this straightforward, even when time is involved and when changes over time is involved. So we saw a little bit of that in the demo so far. So if you want to update the UI in response to changes, well, you need your data to be observable. And Compose is ready for that. We saw in the demo that when you annotate a class with @model, that Compose will know when its properties change. But why did we add something new here? The Android ecosystem has a lot of existing observable constructs, so what gains do we get from this that justify adding something new? Well, we think that the answer lies somewhere between the ease of understanding of the kind of code that we can write this way, and also just kind of the ergonomics of actually using it in practice. So let's talk about live data for a moment, because it really has some neat properties for building UI. Fundamentally, live data is a single value holder. It'll tell you when it's updated. So for our purposes in a UI, only the latest value matters. Live data will conflate its values and only keeps the latest one. There's no such thing as missing an event. You don't actually have an event stream. There's only the latest state. And @model behaves much in the same way in this regard. Maybe? There we go. So let's take another look at an example, kind of like the bookmarks code from before. If you've worked with Android architecture components, view model and live data, you've probably seen something like this before. The view model sort of becomes this hub for a bunch of different observable data, along with some operations to request some changes to that data. So we can reflect the same sort of structure with @model, but you can see something kind of different here. So the hasBookmark method that we used in the example before, it isn't returning a mapped live data that has to be individually observed. It's just accessing internal object state. The list of bookmarks itself isn't even public. @model has turned any normal reads of the object's properties that happen within a special scope into observable subscriptions, even if that read happens layers down the call stack. If I called hasBookmark through some other helper function that I extracted in a refactoring or something like that, even in a completely different class, this would still work. We don't have to turn it into a stream or live data mappings each step of the way. So if we take a look back at our bookmark button from before, we see that our UI can be expressed in terms of these snapshots of state and time, and Compose can help manage the complexity of wiring these subscriptions together for us, even if the actual app model objects might be several layers away across the call stack or across the object reference chain. So Compose will automatically insert these observable scopes for us in composable functions. We don't even have to think about it. So let's go ahead and recap on that. So we need observable data. Compose will add app model classes as a new tool that we have available. But the cool thing about it is that it allows for this sort of cross-cutting observability. So we can write less plumbing and subscription management code in our apps. But the thing is that all these other observable and reactive systems are great. You don't have to leave them behind if they're a natural fit for what you're doing, especially if it makes sense in other layers of your application. So if it makes more sense for the bookmarker at this particular layer that I've defined it to return a live data or flow or something from has bookmark, then we can still support automated but explicit subscription management by using an effect function, kind of like this. One more. There we go. So that's kind of the tour of the background behind some of that. So really what's left for us around data flow is kind of documenting recommendations for the question that's kind of left that you're probably all asking yourself, which is, which of these tools should I use when? So kind of establishing some of these guidelines and best practices are still kind of a work in progress here. So more things that are work in progress. I hear a lot of questions about how to work with resources in Compose and kind of what we plan to do there. So let's talk a little bit about that too. Again, this is current thinking, subject to change, but this is kind of where our heads are at the moment. So when it comes to using resources in a UI toolkit, we kind of think that we've learned a few things along the way, and this is kind of a big one. So really, we need to avoid too many overloads. Some of you might recognize where these are from. We have a lot of ways to set an image.
It's a convenience.
It's very convenient. But the thing is that this makes the view in question huge in terms of its own implementation, but even worse, it means anything that tries to wrap or reuse one of these in a composable fashion has to reflect the whole capabilities of the API surface. We don't want this. So it's annoying for us to maintain, and it's even more annoying for anyone who wants to build something on top. Now, there are a lot of reasons why you might want to offer overloads for your own composable functions, and we would really be doing you a disservice by asking you to multiply that by the number of overloads that you might need to cover for this form of completeness, because some underlying piece that you're relying on offered all of these different ways of doing a single thing. So that's something that we'd kind of like to avoid. So we've also seen a lot of other libraries appear to fill the gaps in between what Android views offer and what you need in your app. So image loading libraries are a really great example of this. There's a bunch of great ones out there. And they apply different loading and caching policies for images, tie into lifecycle, so on and so forth. But really, this is because a lot of resources are dynamic. They might come from the web. They might come from a disk cache or plenty of other places. And tying into the appropriate lifecycle events as signals, it's really not always fun. There's a lot to get right. So by focusing so much on static resources in what we offered, we kind of created this privileged type of data. It created a blind spot for us when we were looking at the system kind of from the inside. And it should be much more straightforward to write these dynamic resource policy layers, and static resources should have to play by the same rules, so using the same public API surfaces to operate. So coroutines are awesome. Ramon mentioned sometimes I won't shut up.
Yeah, you never shut up about it. You're not the only one.
There are more. So we still have a few issues to work out with the experimental compiler around generating suspending code. So we haven't done a whole lot here yet, but our intention is to standardize on coroutines as our async primitive for working with resource loading, whether that's static or dynamic. So Android's R class is also pretty convenient. Having a bunch of symbols that'll autocomplete for the resources in your app is pretty nice. We'd like to keep that sort of convenience, but really all of them being ints is not so convenient.
And I ran into that yesterday while building that demo. I would get a crash because I had the PNG files and an XML file with the same name, so the runtime would pick the XML file and try to load it as a bitmap, and
yeah, you had some fun with that.
It took us 5 minutes to figure it out, and we wrote the goddamn thing.
All right, I think that we might be able to squeeze one more into this list if someone will get out of the way there. OK, so layering is a pretty great idea, too, because once we start talking about type safety and resources and avoiding overloads, the natural question comes up, why should any of this be specific to Compose? We're really kind of looking at how working with APK resources might be made better whether you're using Compose or not. And while we're talking about things that are great, whether you're using Compose or not, let's go ahead and talk a little bit about view compatibility. So we like Kotlin itself so much because you can adopt it in an existing project at your own pace, incrementally, just a little bit at a time, one class at a time, one test at a time, et cetera. So we're designing Compose to be used in the same way. So if you have an Android app today, you probably have a lot of views, layouts, maybe even fragments that you've extensively tested, so they work. Even once Compose graduates to a stable release, rewriting your existing and working code up front probably doesn't sound so great, so you don't have to. So let's take a look at a couple of the things that we have in mind here and how this might look once we spend a little bit more time here. So the first step in interop for us is being able to use just a little bit of Compose inside an existing app. The API for this is about as simple as it gets. It's just one annotation. And this may look familiar if you saw our talk from I/O earlier, that you'll be able to annotate a composable function. It'll ask the Compose compiler to generate a view subclass for you. This will host an instance of that composable function with appropriate setters, so on and so forth, that you can use to feed it data in the same way that you would via its parameters. So this will let you use Compose alongside your existing view-based UI. So this still isn't implemented yet, but we're pretty confident that this is the way to go. And it's kind of the way that things always go, right? It's like the things that you're most sure about are the things that you do last. So.
Well, someone has started working on this, it's just not finished.
Right. So the next step is a little bit less certain, and this is something that we're going to be doing some prototyping on. You can follow along with us in AOSP as we kind of play with some different ideas. So even if you dive into Compose head first, you'll probably still need to use views within that UI at some point. Maybe you're integrating a third-party SDK that doesn't offer Compose integration yet. You still want to be able to use it. So one idea that we've had is to leverage the new view binding feature that you might have seen in recent Android Studio builds. So if you're not familiar with it, if you have a layout XML file that looks something like this, view binding will generate some code that lets you consume it like this. So you get a type-safe object generated for you that you can use to bind values and listeners to it in code. So you could imagine that turning into something maybe like this when you use it from Compose. While this might be nice for giving life to some layouts that you've already set up, it implies some additional work if you just want to use one custom view. Another idea is that we could use the composition system itself to directly manage a view hierarchy. The Compose compiler and composition runtime were originally designed to manipulate the view tree directly. So here, rather than reusing layouts, you could use any existing view subclass as if it were native to Compose UI. But a limitation that this has is that it might make things look a little bit too similar. There's really a lot of mismatches at the boundaries, and some things, like most notably edit text, comes along with a lot of gotchas when you're trying to use it in this sort of reactive style where the single source of truth lives outside of that view. So the existing view implementations still fundamentally want to own their state, and layout contracts work differently, so on and so forth. So we're trying to figure out like what the right balance is with some of these things. So this, like some of the other design spaces that we just talked about, are going to be occupying a good bit of our time over the coming weeks. So we want to be sure that interop with your existing code is as straightforward as we can make it while not leading you down a path that ends up creating additional work if your constraints change. So we'll keep you updated as development continues, but hopefully by now you're asking another question.
So you've heard what we can do. You've heard what we're trying to get to do. But how do you play with it? Well, today we've published a brand new website, so d.android.com/jetpackcompose. We've updated the content in the Jetpack Compose website, including, for example, how to file bugs. So please go check that out. As part of that content, we've published a tutorial. And the tutorial will guide you through the basic principles of Compose, kind of similar to what we've done today, but much more in detail. So please go check that out. You can read through it, and it will make sense. Or you could go and download the new Android Studio build that supports Jetpack Compose. It should be up soon, I think. You will also get a new template. We have a template for a Compose activity that will set up all your dependencies and everything, so you don't need to go read random blog posts that will tell you how to set it up. You can try the new preview that we showcased at the keynote. You'll be able to preview what you're building with Compose. You'll be able to see the sample. So we published Jet News as our sample. It showcased everything that is there now and how you can use it to build this news article app. And then other things that you can try while you're here at the Dev Summit. There's 2 Code Lab sessions happening. The Code Lab is also available online if you're streaming. And we have 2 talks that you should go check out. What's new in Android Studio, where Tor and Jay will walk through the tools that we're building for Compose as part of that. And tomorrow we have a talk from Leland, who's in our compiler and runtime team, and will explain a lot more on how the insides of Compose work and kind of demystify the compiler and what we're doing behind the scenes. Thank you very much.
Thanks.
Thanks.